Welcome, everybody. Welcome, everybody. Thank you for joining us today. We are super excited to host this community session for all of you. Today, we're going to be talking about agent frameworks that Sandi has been researching with her company, and she's co-authored a paper. But before we do that, we're going to do a quick icebreaker. We're going to talk about what our favorite childhood characters are. So without further ado, I'll start. One of my favorite childhood characters was Hobbs from Calvin and Hobbes, the rambunctious duo, dear to my heart. And Sandi, what was your favorite?
Wait, but before we move on, you can't not show everyone your stuffed animal.
Oh, yes. Inspired by Hobbs and Tigger, my favorite animal, Tina.
That's so great. Mine was Kim Possible, or at least one of mine was Kim Possible, because I thought she was such a badass, and I kind of wanted to be a spy when I was younger. What about yours, Sarah or Juan?
We have so much in common. I too wanted to be a spy at one point in my life, so I love that. And who doesn't love Kim Possible? That's so great. So I'm guessing this is like cartoon character that we're going with. If I was to go like old school, like first cartoon character I loved, it was definitely Winnie the Pooh. So I also am called a bear sometimes, and I do love honey. So we have that in common. Popcorn to Juan.
Well, my favorite, you don't even know about it, is called Johnny Quest. That was a cartoon from the days, 70s, you know? But if we want to talk about something more recent, I really enjoyed Steven Universe, if you saw it. That is very recent. And now popcorn to Eva.
Okay, I'm not very big in cartoon because when I was growing up, the cartoon wasn't too much existing. But I can tell you a book character like this Pippi Longstocking. I think that's the one, and she was very inspiring, especially her motivation to go to school was because she go to school because she get vacation, and that's what was interesting for her. Why you go to school, actually? Why you go to work? You get vacation time after. That's what.
It's funny and very realistic for a cartoon character.
That's funny. Dawn or Raj, next. Popcorn. Favorite cartoon character or childhood movie character growing up?
So for me, it was Popeye the Sailor Man. I used to watch it a lot, and known for his muscular features, unique speaking style. I don't remember like a lot of the characters from the show now, but I remember Popeye. So yeah, that's my favorite one.
Calvin and Hobbes was definitely righteous. I mean, it was one of my favorite cartoons. It was one of my favorite gifts to give people that were having a rough time because it was just so funny. And he was so lippy. But the other one that comes to mind was Marvin the Martian. I always liked just sort of the, his sort of clumsy, sort of arch villain kind of approach to things. So.
Mm.
Nice. Thank you, Dawn. Anna, if you want to join in, we're doing favorite childhood characters or movie characters before we get started. A quick icebreaker.
Ooh, I love that. Adventure Time, if y'all are familiar with that show, was my all-time favorite growing up and was actually what inspired me to spend the 2 years of my career before starting a startup with my dad in the film industry, because I just loved it so much that I wanted to try to do something like that. Still working on cartoons actually on the side.
Nice. Yeah, maybe there'll be an agent that'll come up with zany characters that we can all enjoy. I think this is an exciting time in generative AI. And speaking of generative AI, Sandi has a presentation for us. We're going to be talking about AI agent frameworks. She's done a comprehensive survey and co-authored a paper with her company. And here at AI Makerspace, we do these community sessions because we're all about fostering a collaborative and supportive environment to build, ship, and share best practice content and documentation for emerging tools. And our ethos here is to give first by sharing knowledge and through teaching. And that's what we're going to be doing here today. So without further ado, I'd like to hand it over to my friend and community member, Sandi. Take it away.
Thanks, Christos. So my name is Sandi Besen. I'm an applied data scientist at IBM. And I'm really excited to be here today and share our insights with the community. So I'm all about open sourcing things and making sure that everyone can benefit and grow our technologies. So does everyone see the screen? Wonderful. Okay, like thumbs ups. Awesome. So like Christos mentioned, just a couple of weeks ago, my team and my team is myself, Tula Masterman and Mason Sawtell from Nudesic, which is an IBM company, and Alex Chow from Microsoft. So we all worked together to publish a paper on the emerging landscapes of agent architectures. And that paper really came about because we were eager to work with different agent architectures. And as we started working with them, we understood different patterns that started to emerge. And we found a lot of similarities in the types of design choices that the architectures chose, as well as some differences, and saw how that affected their performance. So what we really wanted to understand was, for the community, how could members and developers make better design choices that could lead to stronger agent systems? So that's what we set out to do in this paper. And because it is a meta-analysis, it does draw on observations and research from the industry. So there's lots of papers references. We have 38 reference papers that you can read from the full text, as well as our own experience from the field. So today, we're not going to cover every framework and every architecture that we covered in the paper because we would be here for several hours. But we're going to cover three main things. And if you'd like to read the full text, Christos can link it out in the chat. So today, I want to make sure that we understand the current capabilities and limitations of existing AI implementations, as well as share those insights that we gained from our observations and key findings, as well as suggest important design implementations or design principles that can make for stronger agent systems. And below are some of the agent architectures and frameworks that we listed and referenced in our work. So I'm a big AI advocate. And because I'm a big AI advocate, I think it's really important that we understand the competencies, but also very much the limitations of AI at the moment. And language models at the moment are extremely capable, especially compared to where they were a year or two ago. But as we're moving more towards a tool calling an agent system rather than a chat-based system or a question and answering system where you would just answer based on document or context, it's really important that we improve upon these four key concepts. So one of those is reasoning. And I'll go into a little bit why reasoning is so important, but in general, reasoning is really just the foundation of human cognition. And without reasoning, we wouldn't be able to understand multi-step problems, create complex plans, or even refine our plans based on new information that we have coming in. So reasoning is perhaps one of the most important key components to a strong language model. And of course, having a strong language model reflects on having a strong agent system, as language models power agent systems. As well as reliability. So reliability is also extremely important. And I don't mean reliability as we must get the exact same answer every time you execute something, but something must be valid and proven true each time it's executed. It needs to be a logical conclusion each time it's executed. And that's really important when you are trying to scale something and it's being done at an enterprise level or a very repeatable. So 2 key concepts. The third one is bias and fairness. Now, this one is inherited from the language model. So because agent systems will go into both single and multi-agent architectures, but especially when we're talking about multi-agent architectures, having multiple language models work with each other inherently will increase the risk for bias and unfairness in result, because we're having one system that might have biases interact with another system that might have biases. So that is an exponential increase in the amount of biases that we're going to have depending on how many agents that you add in. So making sure that the language models, or that there's guardrails to control bias and fairness, is really important for the future success of agents as well as language models. Now, last but not least, is evaluating performance. There's been a lot of rumor that you may or not have heard that, and not even rumor anymore, but has now been mostly proven to be true, that benchmarks and evaluation benchmarks have been found to be potentially included in the training data of a language model. Now, that's one issue. However, we know that there aren't a lot of benchmarks out there for agents. There's a lot of standardized exams type of benchmarks out there, but not a lot of benchmarks that actually assess the capability of a team of language models working together. So that's a gap in the field right now that some companies are working to address. But the companies that are mostly, not all, but mostly working to address it are also the companies that are creating the agent frameworks. So it's kind of a funny there, because obviously someone who is creating an agent framework, they're going to perform well against their own benchmark. So there's some element there that we really are in need of a agent framework that that is not biased and also not created by the creators of different frameworks. So that being said, this is my call to action to everybody who might be interested in contributing to the community. These areas, by improving either one or several of these areas, would be contributing to making agents a stronger solution and more capable in the long term. So I'll pause there, let everyone absorb. I just said a lot and we're only at the beginning. And now I'll move on. So, quick water break. So the importance of reasoning and tool execution. Reasoning is an inherently an important thing for people as well as agents. But if language models or agents don't understand their task, they might misunderstand it. They might generate an answer that doesn't make any sense, or they might not take multiple steps or reason correctly through multiple steps. And if they receive new information that contradicts any existing information, they might not be able to revise their plans to make sure they're still on the same correct goal of achieving their task. So that's extremely important, and perhaps one of the most important elements of agents. And then tied very closely with that is having access to tools. So if an agent doesn't have access to tools, and by tools I mean either semantic functions or functions themselves, they can't interact with the outside world. And why is reasoning so interlinked and dependent with tool calling? Well, if a model can't reason correctly, then they might not be able to call the right tool when the time comes. And we'll see an example of this in the next slide. But one key insight I wanted to bring out here is we saw looking through lots of different frameworks that most agent implementations contained a specific planning phase. And what I mean by that is either, there's many approaches you could take to having a planning phase. You could either break the task down into subtasks. You can select from multiple different plans, or you could even have a specialized AI model be used as your planning model before it's passed off for the execution phase to the generative model. So these are all different approaches that you could take, but what we saw across the board is that most successful agent frameworks had this planning phase in the beginning before it executed anything. So that's something I wanted to highlight and that you can read more about in the full paper or full text. So now we'll move on to an example of why reasoning is so important. So I have two models side by side here. The model on the left is Llama 3 70 billion instruct model. The model on the right is Mixtral 7 billion instruct model. And I gave it the same prompt. It says, you are helping your friend plan their day. They need to go to the library, the post office, and the bank. The library is open from 9 to 6 p.m. The post office is open from 8 a.m. to 5 p.m. The bank is open from 10 a.m. to 4 p.m. So what is the shortest period of time which all places are open? So this is a problem that takes multiple steps with constraints and requires you to reason through to find the correct answer. We'll see that the model on the left, the Llama 3 model, was able to understand those constraints, reason through, and it arrived at the correct answer, which is 10 a.m. to 4 p.m. That is a duration where everything is open. The bank is really the constraint there because the bank is open for the shortest amount of time. Whereas the model on the right, first of all, it jumped immediately to a conclusion. It really skipped that planning phase, and it got it wrong. So it made an assumption, skipped to a conclusion, and got it wrong. So we see how important that reasoning is in here. And how that ties into tools is, I know in this example, we didn't call on the model to use any tools. But if we were to, in an agent implementation, then I would really put money that the model on the left, the Llama 3 model, would perform much better in selecting the right tool to call than the smaller Mixtral model that has poor reasoning skills. Not necessarily because it's smaller, but because it just has poor reasoning skills. All right, so now let's get down to it. We have single agent architectures and multi-agent architectures. Pretty self-explanatory there. There's one agent in a single agent architecture and multiple agents in a multi-agent architecture. Where it becomes a little bit more nuanced is the sub-architectures in the multi-agent architecture. So you might have heard of AutoGen. AutoGen is a good example of a horizontal architecture. And why it's a good example is because every agent is put in a group chat, and every agent is allowed to correspond with each other. There's no limitations in terms of how they are able to communicate with each other. Whereas in a vertical agent architecture, there's limitations on the communication patterns. So there's a lead agent, and that lead agent is able to communicate with their sub-agents, but those sub-agents are not able to communicate with each other. So it's a different structure of how communication flows, and that makes the difference between horizontal and vertical. Now in practice, there's a lot of architectures or frameworks that really sit in the middle of them, that they're not pure, right? And that's a design choice that when you're looking at the use case and you do some experimentation, you can decide what is best for your task or your goal. However, something that's pretty much across the board is that all agents have personas, and those personas have specialized skills. And every persona that has a specialized skill is typically also given specialized tools. But just having access to those tools is not enough. They also need to have a description of those tools and an understanding of how to use them effectively. So we've covered that most agents have solid reasoning skills, solid planning skills, and solid tool calling abilities, as well as personas, tools, and a description of how to use them amongst these different types of architectures that are dependent. So that's all the background knowledge, right? Now let's get into actual design principles of when to use such things and how to work with them. So the first part of that is selecting multi versus single agent implementations. One thing I want to emphasize is that our findings found that both multi and single agents are useful and good for solving challenging tasks. It just depends on the task. So one example, sorry. One example of single agent patterns, or when it's best for single agent patterns, is when you have a task that is narrowly defined, where there is a specific list of tools and the process is also well defined. Another thing is that because there's only one agent in a single agent framework or single agent pattern, they don't face any poor feedback or any distractions from other agents around them because they're not privy to any other conversation that might be able to confuse them. That being said, there are some drawbacks as well. So for instance, if that agent doesn't have adequate reasoning abilities, it might get stuck in an execution loop. And it might try to go down the wrong path, and there's no other agents to really bounce ideas off of or make sure that it is moving in the right direction. So that's where multi-agent patterns come in, is because those agents are able to work together and provide each other feedback. They can keep each other on the right track. They can check each other's work, and there's potential for more validation along the way. Another good thing about using multiple agents is because each agent has a specialized role, you can actually parallelize the tasks that are being performed, and there's no dependency on one agent completing a task and having to move on sequentially to the next task. So a good example of this is if an agent wants to bake a cake. You have a team of agents in a bakery to bake a cake. And one agent's job is to assemble all of the ingredients and make sure everything is set up correctly and preheat the oven and kind of be that sous chef. And then you have the actual chef that combines all the ingredients and stuff. So that sous chef can heat the oven and then move on to prepping the ingredients. And when the ingredients are finished being prepped, the chef can come in and combine all the ingredients and make them while the oven is still preheating. But if you had a single agent, they might not be able to move on to the next set of tasks until that is already complete. So that's one advantage of having multiple agents, is that because you split them up amongst skills, they're able to accomplish more things independently at the same time. However, we talked about a lot of the drawbacks earlier on in this session. And one of them is, we spoke about the bias and the risk. Well, the more agents, the more risk of erroneous responses. So that is one potential drawback as well. Another really key component in design choice is information sharing and communication. So we've discovered that multiple agents have a greater tendency to get caught up in the niceties. So what do I mean by that is they might, say, "Good job, Agent 1, you're doing so well, continue the good work." And although that's great that they talk to each other so nicely, that can also be detrimental because they're using tokens and not contributing directly to actually completing the task. So we found that one potential approach to address this is by robust prompting to encourage the agents to stay on task and focused. Another way of managing communication amongst the agents is using something called message filtering. What I mean by message filtering is an agent can either subscribe or publish to a chat, but the agents that are subscribed are only subscribed to different agents where that context is relevant for the task that they're completing. So that can help to reduce some of the group chat noise where they might be receiving context from every different agent that's not necessarily relevant to the task that they're trying to do. So those are two potential solutions for solving those problems. Something else we noticed is that in vertical architecture specifically, and that's, remember, because vertical architectures, the lead agent is able to communicate to the sub-agents and vice versa, but those sub-agents are not able to communicate with each other. So they're not privy to all of the conversation history that's going on. And in that case, they can actually assign the agent to do something without realizing that that agent doesn't have the context necessary to do it. So an example of this would be an agent might ask their worker agent or their sub-agent, hey, can you, when you're writing this policy, can you make sure that addresses the company guidelines? And that agent might not have access to the company guidelines, but that lead agent doesn't necessarily know that. So one thing we have seen that works to address this is explicitly including information about the access and the information that each agent is privy to in the system prompt. And that has helped to kind of move around this and remediate some of those issues. Something else that is really important and a different design principle that you can incorporate is role definition in dynamic teams. So one thing that we found is that, and this is through both our own observation and many different studies that also address this, is that teams with clear agents are about 10% faster at completing the tasks than teams without clear leaders. And that's really important, right? Because that will take less iterations of a team working together in order to accomplish the same tasks. And that will also save tokens and, compute and all of those things as well. So establishing a clear group leader is very important to improve overall performance. And that's something that our team has definitely been implementing as we design our own agent framework. Another thing is proper role definitions. So it seems obvious, but we don't always understand the impact that it can have if we are lazy in producing our system prompt. So it can actually make the difference in understanding the assigned role that the agent has. It can understand when it should step in and take certain tasks. And it can even make the difference in understanding when to use certain tools or even not hallucinating capabilities that they might not have. So clear role definition is very critical and something that's important for single or multi-agent architectures. And then last but certainly not least is dynamic teams. So what I mean by a dynamic team is we've seen, and if you have heard of Agent First does a good example of demonstrating this topic, and that's in the resources of the full text if you're interested in looking that up. It is a process before the execution of any task where the team is recruited. So the team is recruited based on the task that is given to the team, but it's dynamic, which means that the team is not, there isn't the same static team of agents that works on every task. It's based on either, there's several ways to do it. Either you can use an LLM to actually create the persona of the team and structure the team, or you could do it a little bit more constrained, which I recommend for now, and actually have a set of personas that you can choose from and have the LLM decide what persona is best for this type of task right now. But the really cool thing about that is that it can change depending on the subtask. So during an evaluation phase, you can assess how much each agent is contributing to the task. And if an agent isn't being a good contributor to completing that task, then they can get replaced in the next round of iterations. So having that dynamic team is very important and making sure you have the right agents at the right time.
I don't think so. I don't remember. Probably not.
All right, moving on. Maybe we can mute.
I think it's
Yeah, it's been
might
muted
be.
already.
Wonderful. Thank you, guys. Okay. Last but certainly not least, because this is something that we're all aware is very important, but is human in the loop. So there is pretty much unanimous consensus that having a human in the loop right now is the way to get the best performance out of an agent system. And there's a couple of reasons for this, two of which we addressed in our paper are that language models tend to commit to their answer really early on. And we saw that in the example that we had for reasoning, when the mixtural 70 billion model jumped immediately to a conclusion, but it didn't go through the reasoning steps that were necessary to actually arrive at a correct answer. So it committed really early and it was actually incorrect. So one thing that can be used to mitigate against this is by implementing feedback. Either agent feedback and asking it to assess its own performance and make sure that its steps it takes make sense, or human feedback. That's also very important. Another thing is, although agent feedback is great in some ways because it can be the preliminary force that checks for logic and checks and validates to make sure the agent is on the right track. Agents can also be susceptible to feedback from other agents that's not necessarily true or grounded. So an agent that gives another agent incorrect information, there's no way for those agents to validate if that's correct or not. And they're susceptible to incorrect information. So including a human in the loop there is very important to make sure that agents are providing adequate information when giving feedback as well. We covered a lot. And like I mentioned, you can read more about each subject in the full text. But I wanted to just recap on the 6 things that we covered, or the 6 main things that we covered, and say that, we noticed across the board that successful agent implementations tended to have at least one of these principles. So those are well-defined system prompts, dynamic team structures, human or agentic feedback, intelligent message filtering, and that falls into the communication patterns, that dedicated reasoning, planning, execution, evaluation phase, clear leadership, and task division. Those are kind of the guiding principles that we arrived at through our meta-analysis and research in the field of what makes a strong agent architecture or agent framework. And that's all I've had today. So thank you very much for having me. Really excited to present this research. And if you have any questions, we're happy to answer them now. And if you have any further questions or want to collaborate, feel free to reach out to our team. The emails are here. We can also post them in the chat.
Thank you, Andy. Thank you all who joined and are in attendance. If any of you have any questions, please feel free to raise your hand or unmute yourself and ask them now, or continue to post them into the chat. I'll start with one that kind of popped into my head as you were talking, Sandy. That's really important. So these wasted tokens, when the agents are kind of chatting back and forth, because most of them have this predisposition to kind of be nice. And even recently, when I was working with Juan, we had 2 agents kind of talking back and forth, and they just kind of default to saying, "Hey, hello, how are you?" And without that right role, without the right instructions, without the right access to tools, which is so critical. what can you recommend to folks from what you've seen that can reduce that wasted effort?
Yeah. So without directly modifying the model itself, because that's one approach you could use. But if you are on the applied side and you'd like to use an existing model, your best bet is through prompting. And what I mean by that is explicitly stating that you are only to communicate in ways that are effective, in ridding yourself of erroneous chatter, and urging the agents to just stay on track. And having a leader agent as well really helps with that, because agents don't get caught in this like loop of trying to chat with each other. They have someone to keep them in check. So that's something we've also found.
I have a question. Can you mute? I'm across the room from my dad. Sorry about that. I have a question on the human input that you mentioned to uncover potentially incorrect assumptions or hallucinations. What cadence of input do you suggest? And the I guess counterintuitive thing here is that the reason why we're making agents in the first place is to try to remove work from humans. So what's the right balance to still get good output, but still, get that efficiency from using agents in the first place?
Yeah. I would say that answer really lies with who your audience is. If your audience is a large enterprise, they like to have more control over the things that are being outputted. There's typically less trust in the process, rightfully or wrongfully. But personally, I think that a good approach would be every kind of phase of something. So to have the output checked at every stage where it makes logical sense that there would be a solid output to review. But again, if you are okay with interacting more with the system, it will probably lead to better results, because if, for instance, after completing like 10 iterations, you decide that you actually really don't like something that occurred in iteration number 2, the agents don't have to go back and rework everything, and it would be less expensive for the company. So it really depends on the way that the person or the user wants to work with the system, as well as how much risk they're willing to take.
Yeah, that makes a lot of sense. I agree.
Question here. You saw several frameworks, and I have seen that as time passes, they become better, of course. But I am of the idea that I should build my own agentic solution from scratch. I do believe that for my use case, these frameworks are generalistic by nature. They have to appeal to a lot of audiences, all the industries, all the use cases, because otherwise it's not a business, right? They don't come in targeted flavors. So maybe is there a market for targeted agents for certain industries, or is it a good idea to embrace one of these and adapt it, or is it a good idea to really start from scratch? What is your advice in that regards?
I think it really depends what you're trying to do. So our team is building our own framework, but we're building it not necessarily as a, use this framework because it's better than the rest of them. We're building the elements that we found in the research, and we're incorporating them into a framework. So I don't know whether that will be open source yet or not, but the purpose of our creating it is for our practitioners and our consultants to be able to build frameworks or agent structures for our clients using this framework, rather than having to depend on like a link chain or an autogen or semantic kernel or something like that. So I think if you're doing something that can be done with an existing framework, that is certainly a lot easier than building your own. But if you're trying to do something where none of the stuff out there makes sense, or you don't want to be dependent on the stuff out there, or you want to improve upon it by adding different elements to it, I think building your own is a good way to go. As long as you're willing to put in the work and upkeep.
Yeah, I agree. I think what your group is doing is what I would, and I am doing, and what I would do if I were you. Thank you.
We should share insights with each other. I'd love that if you're willing and open to.
I would love to. Yeah, I would love to.
Awesome.
I have a question here. Technically, it's about the reasoning and how we can prevent some kind of like leakage or some kind of wrong decision to happen. If you're having multiple agents, obviously you're connecting them in some flow or things like this, they're communicating, but there is also a risk, like when one of them is getting into a wrong conclusion, everything else after that is falling apart. So is there any pattern or any kind of way you can kind of enhance this collaboration to be more truthful or more kind of less prone to error, like these chain errors or things like this? Any pattern that can help?
Yes, there are a lot of different approaches. A few come to my mind. One of them is called React, and it's an approach or Raise that's also kind of a modification of React. And React is really where I see people shaking their heads, so they've heard of React. And so there are these approaches that you can use to enhance reasoning. Are they going to make the example that we saw with the Llama 3 and the 7D and the Mixtral 7B model? Is it going to bridge that gap of difference? I don't know. But it will certainly improve a little bit upon the capabilities of the model as they are without any sort of additional framework or approach to improve reasoning. There are also models that, like Orca 2, that are fine-tuned specifically for reasoning. And so one thing that we're looking at as we build our own framework is which agents should have which type of models. Not all agents need to have the same model. Maybe there's some agents that are better reasoners and some that are better at tool calling, some that are better generally. So that's something that we're also looking at. And so as we do that, we're looking for either strong reasoning models that are open source or potentially looking at fine-tuning our own reasoners.
Yeah, thank you. Very valuable. Thank you. So effectively also, I kind of, from the whole presentation, I'm seeing that the planning stage is very important. So it's kind of looks like that's a key for getting this correctly. Am I correct? Like, I mean, this is one of the most important pieces.
Yeah, definitely. And one of the most challenging pieces, because it's not very challenging for an agent to tell another agent to go do this, and then they execute exactly that. But for that agent to think through the problem logically for themselves is the most challenging. Just like people, right? When we're like, we have to sit there with a blank canvas and think through how we're going to solve this problem. It's much harder than if we're following documentation that tells us exactly the next step to take.
Yeah, that's correct.
Definitely. Yeah. Having those roles, having clear definitions, the planning stage, like you were mentioning, access to tools, being able to call them correctly, limiting the snowball effect of those areas with multi-agent systems. Excellent presentation. Thank you for presenting this information, your findings from the collaboration that you did with your company. And if anyone has any more questions for Sandi in the future, you can connect with her on LinkedIn. Posted that in the chat. I'm also gonna drop a feedback form right now. And yeah, if you enjoyed this, we do these sessions weekly here on Wednesdays.